Hello, my name is Megan Litchfield. I am a student of the University of New England, and I am currently taking organic chemistry online. Today we are going to be covering the albuterol molecule, its chirality and its functional groups, and the different enantiomers that are in that molecule. All right, here is our albuterol molecule. Here's our molecular formula. Here is our IUPAC name. We have 2-tert-butylamino, 1-hydroxyethyl, 2-hydroxymethyl-phenol. Phenol is our parent chain. It's actually a cyclohexane with our 3 pi bonds that makes us an aromatic ring. And then this alcohol group right here is what makes it the phenol. So this is carbon 1, carbon 2 is our hydroxymethyl, carbon 3, and then 4 is where we branch off. 4 is in this bracket. We got 2-tert-butylamino. This right here is our amine. It is a secondary amine since it's got 2 connection sites to it. And then we have our alcohol group right here. Now, as far as chirality, this right here is our chiral center because these carbons right here are sp2 hybridized. This carbon right here is a sp3 hybridized. However, it does not have 4 different substituents. It has 2 hydrogens. This one has 4 different substituents, so this is our chiral center. Now, for the albuterol medication that we give in the ICU, we actually give a racemic solution of it. So albuterol has 2 isomers, it has 2 enantiomers. Since it has 1 chiral center, it does not have a diastemer. It technically can have constitutional isomers, however, we do not use those in the ICU or like the medicine practice as far as I know. So our first enantiomer is our R-albuterol. Another term for this is levalbuterol. This is the, quote, inactive enantiomer. However, we use it in the ICU for patients who are tachycardic or have heart ectopy because this one has less of a beta-adrenergic effect to it, and it still gives us the bronchodilation that the racemic gives us as well. But this is only used for the patients who have the CNS problems and the sympathetic reactions. Okay, so you see right here, our oxygen group is our priority. This hydrogen back here is number 4. It's going to the back. That's our 4th priority. Our 2nd priority is this nitrogen right here. And then our third priority is this phenol right here. And you see it's going counterclockwise, so that is our R enantiomer. All right, this is our S-albuterol. This is where we have the S configuration, where we're going counterclockwise at this chiral center. As you can see right here, the hydrogen is coming at us, but this is also the 4th priority, and our 1st priority is going towards the back, so this will give us an S. This is the, quote, more active albuterol enantiomer. However, as I described before, the levalbuterol, the R-albuterol, still works for bronchodilation. It's just a little less effective if you give the 2 separately. It's more effective to have the racemic solution in medicine. So this is a pretty cool example of how 2 enantiomers can be used in medicine, especially it's the racemic, how they both can complement each other and make it even more effective. I also want to point out how here is our IUPAC naming of it, and the difference in between the 2 molecules is this right here. This tells us the chirality. See, it says 1s, so this one right here is going to be going counterclockwise, okay? And then the other one right here, you see how it says 1r. This one's going clockwise. That gives us the direction of the chirality.